2.1. 2.1, the super fun stuff. Are you guys ready? No? Okay, radicals. 3 lessons. You're going to survive them. You're going to excel at them. It's going to be okay. But we are going to put transformations with them, which is going to complicate some things. But we're going to go at a small pace, and we will be okay. All right. So, all right, here we go. So functions involving radicals. Do you guys remember the parts of a radical? Okay. So everything under the radical sign is called the radicand. Okay. And then the number, the little tiny, tiny number on the root is called the index. And it tells you what kind of root you're dealing with. So this one, we're dealing with a cubed root. The 4 would be your coefficient. And then the whole thing would be a radical. So that goes back to, was that grade 11? Oh, feels like a million years ago.
I remember thinking about that before the grade 11 exam.
Okay, there you go. So I'm going to tell you, I want to say confidently, but I can't. We're probably going to stick with square roots. Okay? So we're going to stick with indexes of 2. But this one here, when no index is stated, what do we know it is? It's 2, right? So if no index is stated, we know that it's the invisible 2, and that it's just a square root. Okay, look at us. Look at us doing grade 11 stuff. Okay, we're going to graph your first one. Okay. I can tell that you're all super excited. We're going to be really purposeful in the ones that we select to graph. The x values that we select to graph. What are we taking here? We're taking the square root of x, right?
Could we take perfect squares?
So I'm going to take some perfect squares. I'm not going to use negatives, because why? Can I take the square root of a negative number? No. So that wouldn't happen. Can I take the square root of 0? Yes.
0.
It is 0. Can I take the square root of 1?
No.
Yes. You guys then. All right, what's my next perfect square?
4.
Okay, good. Good job, guys. What's my next perfect square after that? 9. Okay, we'll just stop there. Okay, so to find the y's, I'm just square rooting the x's. So the square root of 0 is 0. The square root of 1 is 1. Square root of 4, 2. Square root of 9 is 3. Okay, so we're going to graph this now. You ready?
Does it look pretty?
It's going to look pretty. Hey, it's going to look pretty. Just trust me on this. I'm trying to find a pen. Okay, so we know that we have to go up to like 10 on our x-axis and 5 on our y-axis. Everybody would agree with me on that? So every single tick is 1 unit. Are you guys okay if I do this? Well, you have to be now. I committed to it. I didn't use an erasable pen. Oh, I'm a wild child. What can I say? Okay, 0, 0. 1, 1. Now I go to 4, and I'm at 2. And I go to 9, and I'm at 3. Now, could this continue this way? Yes, because what would be my next one here? 16, and then 25, and we'd go on from there, right? So Okay. All right. So I did something there that I didn't even really inform you guys of, and I just did it because I'm trained to do it. There's a little bit of a bubble between your first point and your second point.
What does that mean?
Okay, so let's pick some values. They're not going to be nice. I just need you to know this. They're not going to be nice. Pick some values for me that are in between 0 and 1.
0.5.
Okay, so we got 0.5. We'll go 0.75. Is everybody okay with those two numbers? Okay, so I'm going to take, oh, I got to turn on my calculator. So I'm going to take the square root of 0.5. Do you guys recognize that number?
Yeah, it's like.
It's root 3 over 2. No? Oh, no, sorry, that's not root 3 over 2 because that's a 0.8. This reminds me of epsilon is what it reminds me of. Or is that root 2 over 2? Is it root 2 over 2? Okay. Okay. So then I'm going to go second function 0.75. Those were a number that we picked. Okay. So this is, I'm trying to explain, do you see how mine kind of like bubbles up in between those? It's not like a straight line between them. So I'm trying to show you guys why I did that. So here's the thing. So at 0, 0, it's the same point. And at 1, 1, it's the same. Like the x and the y are the same values. But what do you notice here? So at 0.5, I'm at 0.7. They're not the same, right? They're not, it's not a linear. Whoa. So it's not the same. It's not like, so it's not 0.5 and 0.5. The y is greater than the x. And then here again, at 0.75, the y is still greater than the x. So we end up getting this bubble between the first two, and your graph should always have that bubble. No matter if we do any transformations on it or anything like that. Okay, so there's your basic radical graph. All transformations are going to be done off this graph. Okay? Hi. Why are people keep... Who's that?
You just didn't say anything. You just looked in and kept going.
Was this like a student?
No.
Oh, a
Definitely
man.
not. Oh.
Weird. Okay. All right, so now we're going to do transformations. So we're going to do all of our transformations based off this nice little table here. This is a really easy table that you guys can remember, right? Yeah? You can do perfect squares and their square roots. And you just know that there's a bubble between 0 and 1, right? Okay. So, transformations, do you recognize this? Looks kind of similar to what we've done before, but now we've thrown a square root sign in it instead of the F. Okay. So the A is a vertical stretch. Everybody good with that? If A is less than 0, so what does that mean if A is less than 0?
Negative.
It means it's a negative number. What's going to happen? It'll be reflected in the x-axis, right?
Do we have to state the domain and range for the first?
Oh, geez Louise, we do. We do. Geez Louise. Okay, let's go back. And I was just excited to move on to transformations. Let's talk domain. Right. So this one, because we just talked about we couldn't have -2. We couldn't have -1 because we can't take the square root of them, right? Like if I have -1 in my chart here, can I take this? Can we find that? No. So there's like, I can't have that value. So for my domain starts at 0. And we go on to positive infinity. Yes. And then for my range, same thing, right? So we're not going below that 0, and we're headed to positive infinity. Now, once we do transformations, this is out the door. We're going to have negative x values, we're going to be in the negative y values, we're going to be everywhere, but it's due to transformations, okay? But we're transforming this graph. And you guys have done transformations and you're good at them. And it's going to be great. We're going to have a good time. B results in a horizontal stretch by a factor of the reciprocal of B. And if B is a negative number, so again, all that means is negative number, the graph's going to be reflected in the y-axis this time. But you guys have done this before. This isn't a shocking thing. We've done this in every unit we've done so far, except for 4. So it's subtract h, so it's going to result in a horizontal shift, and k is your vertical shift up and down. So I'm going to go back to the chapter 5 we just did. B and h are related to what? The x's, the domain. And a and k are related to the range, right? So I was finding when we did chapter 5, we were kind of putting things in for h that were related to the range, just because you thought you had to have something there. But B and H are domain related, and A and K, so think of the earmuffs, are your range. Okay, good times. I see we're excited. All right. Okay. We ready? We're good. We're good. So what are we doing with this graph? Talk to me transformation-wise. What are we doing?
Vertical shift, 1 up.
Okay, so we're going 1 up
And 2 to
and 2 right.
So we don't have to put, we only put brackets if there's a stretch and a shift?
Exactly, yeah. If there's 2 things happening, you need both brackets. All right, so we can do this based off that first table of values. We know that our original graph, this, has a table of values of this. You guys would agree with me? That's the one we did on the first page. So now we're just going to apply our transformations.
Are you able to do it without the table?
Yeah, you should be able to. Create your new table is what you're doing. Okay, so 0 is going to translate to 2, and 0 will translate to 1. This will go to 3. That will go to, is it better to do all the x's first?
Yes.
Okay, so 4 is going to go to 6, and 9 will go to 11. And now 2 will go to 3, and 3 will go to 4. I find it easier to do all the x's than all the y's, so I'm not flipping back and forth. Okay, let's graph that. So can I ask a question? No, I'm going to make a statement. This is our start point, right? This was the start point on our original graph. So that translates to that point. So this is my new that's my new start point. Okay? We could talk about restrictions under the radical sign if you want to. What are the restrictions of x? There's a restriction on the domain. Yeah, they can never be negatives, but we have a statement under here. Cannot, well, it can be 0, it can't be negative. X can't be, well, it can be 2, because then it would give me 0. So make the statement, make the restriction statement.
What's the restriction?
So,
Can't be less, no, yeah, look, that can't be less than 2, yeah.
okay, so what do we know can't be under here? Oh, sorry, you're not even seeing that. What can't be under the radical sign? Can't be negative. Right? So if I were to make a mathematical statement, x minus 2 has to be greater than 0, right? Yes, everybody with me? Oh, it could be equal to 0 too, right? So x has to be greater than or equal to 2. So that's the restriction. We're saying a restriction about our domain. Now you did learn that in grade 11, but I know that's a little bit of a stretch. But what that means is if I put a 1 in here, if I put the number 1 in for x, what are we going to have under the root sign? We're going to have a negative number, we can't use it. So x has to be all values greater than or equal to 2. So we have a very restrictive domain. That's why my start point translated to 2. Got it? Kind of? Yeah.
Why don't we root it first, though?
Root what first?
Like the x. Like
I'm confused. The radicand is both x minus 2. And you can't treat them as two separate entities. A lot of people make that mistake. Like they think that this is equivalent and it's not. Like that does not equal that. Those are two different statements.
yeah, but if you put like, never mind, I got it.
Do you got what I'm, okay,
Yeah, I got it.
okay. Because that's bad to do that. That's bad. Okay, let's graph it. What do I need on here? 2, 4, 6, 8. Oh, geez, I didn't get my 11 in. So my graph is going to start at 2 and 1. I'll do that one out there. And what shape do I have between those first 2 points? I have that little bubble. Okay, domain and range. 2 to positive infinity. And range is 1 to infinity.
So if you're finding the restrictions, you have to find it in the equation?
Yes. Yeah. And we did the restrictions on in grade 11, and I just assume that you remember them, but I know that that is a bad assumption on my part. But the restriction, so you just need to know that that start point translates, what point does that translate to? And when you get into reflection, sometimes it gets a little bit confusing because you start going in different directions. Okay, next one. Next one, no big deal, but what do we know? We have a coefficient on that x, and what are we missing? We definitely have a vertical shift, but if I have a coefficient and a shift, what do I need to separate them? Brackets. So I would write on your test common factor, right? That would be the thing I write on your test. I got a common factor. And my encouragement to you was always common factor first, if you don't see that. So I'm taking out a -1, which is going to leave me x minus 1. Right? Like you've seen this on chapter 1, you've seen this on chapter 5. You'll get the horizontal stretch correct, but what will mess with you will be your shift. So you have to, common factor needs to have the brackets. Okay, so old table, 0, 0, 1, 1, 4, 2, 9, 3. New table. Oh, maybe we should talk about what transformations we're doing first. We should talk about them. Okay.
So would the restriction just be x is greater than or equal to 1?
So go here for a sec. So negative x plus 1 has to be greater than or equal to 0.
No, but you common factor it.
No, it's better to do it right from the very first one. If I'm doing the restriction, you don't have to do the restrictions for these.
You don't?
No. So I'm going to have negative x is greater than or equal to -1. I don't want a negative x. What do I want? Positive. But weird things happen with inequalities. When you divide by a negative, it flips the sign. So x has to be less than or equal to 1 for it to work.
Do we need to write the restriction every time?
No, but just so you know, you might see it show up in where it says comma, and then it gives you a restriction after. That's how it was built, right?
So we don't need to know how to find it?
No, I want to make you find it, but Kate, I don't know what I've touched today, but I'm covered in pink ink, and I'm not enjoying this. Okay, so let's talk about this. So for my x's, what am I doing for my x's? I'm multiplying, and remember the transformations, the rules still apply. You multiply before you add, so you stretch before you move. So we're going to multiply by -1, and then we're going to add 1. So we're reflecting where?
Y-axis.
In y-axis. We are shifting, I'm running out of room, shift 1 to the right. So that's 1, that's 2, and then I've got a vertical stretch by 3. Whew. Would a mapping rule be better here?
Yeah.
So xy translates to, and this shows me the math I'm going to do. I'm going to do -x and then +1. Oh, that looks really familiar. And then y is going to be 3y. Do you remember the mapping rule from chapter 1? I don't know if that's easier or not easier, but we'll just go with it. So my x's, I'm going to multiply by -1, and then I'm going to add 1. So that'll be at 1.
Does reflection go first?
Always. Multiplying always happens first.
No, okay.
But you're like, a reflection is multiplying by -1.
Yeah.
So -1 times -1 is -1 plus 1, 0. -4 plus 1, -3. -9 plus 1, -8. And these ones are nice and easy. We're just timesing by 3. Oh, so where does my graph start? So this is my new start point.
I thought we couldn't have negative.
I said we could once we start doing transformations, right? Because we've taken the graph and we've slid it over. And our restriction says that all of our x values have to be less than +1. Okay. Let's do some math. 2, 4, 6. I think I need to go on the side. -2, -4, -6, -8, -10. Ooh, I gotta go down to, or I gotta go up to 9 this time. So I gotta adjust my axes here. Okay. So 0 and 1. Nope. That is 0 and 1. What's my point though? 1 and 0. And then I have 0 and 3. And I have -3, +6. Okay, so what's happening between those first 2 points? Bubble. Domain and range. Do you guys need a second to get that graphed? Are we good to do domain and range now? All right, so domain. Where am I going first? Negative infinity, right? We're going far left this time. So negative infinity, and I go to 1 inclusive. And then what am I doing for the y's? Start at 0 and head to positive infinity. Okay, this is exciting stuff. Looking at that, what's the first thing I'm going to do? I'm going to rearrange. I'm going to move that 3 over. Okay, so now I have, yep, I have a horizontal stretch by 1/2, and I have a vertical shift 3f. So really, this is just chapter 1, but it's applied to really specific graph. And so now we're going to do our new table. So x's, what am I doing? I'm just multiplying them by 1/2, right? That's the only thing I have to do there. So straightforward, that one will be 0. That'll be 1/2. That will be 2. And that'll be 4.5.
Do you care if we have decimals and fractions?
No, no. I find that decimals are easier for me to graph rather than fractions. Although sometimes when we're graphing like trigonometric functions, fractions were better, but whatevs. So for the y's, I have to multiply by my -1 first and then add 3. So this would be -1 plus 3 is going to be at 2. -2 plus 3 is 1. -3 plus 3 is 0. So again, this is my start point. So this is going to be the one that like everything goes beyond that. So this one's going to look a little bit weird. I think what I'm going to do is this. I got those halves in there, so I want to give myself a little bit more space. And notice how that I care very little about what's happening here because I know I don't have any points yet over there. Okay, so let's graph. 0 and 3. 1/2 and 2. 2 and 1. And 4.5 and 0. So these are my first 2 points, so I'm bubbling. I have to say my radical graphs are looking pretty good. Not to toot my own horn, but they look pretty great. Okay, domain for this one. 0, positive infinity, range. Negative infinity to positive 3. Okay. Are you feeling educated? Are you feeling like this isn't going to be too terrible? This isn't too terrible so far, right? So far? Okay. All right. Okay. Here we go. You ready?
Is it about to get terrible?
Emma, is it lucky or terrible? What?
Is it about to get terrible?
You can... Sometimes,
Your silence is
sometimes we don't like creating equations for things. I will just say that sometimes we don't like that. This isn't terrible. This one I'm gonna push your limits a little bit though. Because I love you guys and I know how smart you are. Okay, so we all agree that that is the transformation form of radical functions, right? Okay, so determine two forms of the equation. It's going to be so easy to create one. I guarantee you're all going to enjoy creating one. The function transformation of the basic graph. Show algebraically that the two equations are equal. You ready? Perfect, I love it. Okay. Should we put our regular graph on there? Just our y equals root x, just so we can see it?
Is that not it?
Nope, that's not it. Nope. You ready? 0, 0, 1, 1, 4, 2, and 9, 3. So that red one that I just drew on there was our basic, like, something's happened. So this is the one we're trying to create the equation for. Right away,
vertical compression.
okay, so right away you're seeing the squish, right? You're seeing that it's squished horizontally, and that's definitely where my head goes to. But let's talk about shifts for a second. Where are the places, okay, you're correct, there are no shifts. But where's the place that tells me that?
The starting point, which is 0, 0.
It's the 0, 0. That point doesn't move. If there was a shift, that's the only place that we could tell really specifically, because the x is 0, and our new starting point would be somewhere else if it had, because nothing can multiply by 0 to get it to change, right? So if it had a shift in it, the start point would have moved. Does that make sense? So because they share that 0, 0, there are no shifts. All right. Okay. So now that we know that, we can go ahead and start doing the math. So you guys said that there is a vertical compression. You guys see it right away, right? Do you guys see the compression? So how much of a compression is it by? Okay, so my original table would have been 0, 0, 1, 1, 4, 2, 9, 3. Sorry, you can't see that. And so this is now a half, like 1 and x is 1, y is a half, x is 4, y is not 2 anymore, it's 1, right? So you were seeing that compression. Can we solve it? Can we go ahead and solve it for A? Like I think you guys, can you see it mathematically why it's a half? So you guys are saying it's y equals 1/2 x squared. Or not x squared, root x. Right?
But like if it wasn't that easy.
Okay, so that's what we're going to do. We're going to, so this is what we know to be true. We already know the answer. So let's math it out. Do you guys remember how to do that?
I don't know what you're asking me.
I'm asking you to calculate that formula. Use algebra to calculate that formula.
How do we do that? Like,
Okay,
points?
so what do we know? There's no shifts. So we know that h is equal to 0, and we know k is equal to 0. Now, this one, if there is this shift, is there any horizontal shift? So we know that b is 1. So what we're trying to find is a.
Can you repeat why B is 1?
Well, if we look at this graph, what's happening? These points are just dropping down. right? They're right stacked on top of each other. So we know that those points haven't translated, they haven't gotten squishier this way or longer this way, okay? So we know that there's no b value. Well, b value is 1. There's no transformation. We're not multiplying it by anything. So if we substitute everything we know in here, y equals a root, b is 1, x we don't know, we know h is 0, and we know k is 0. So what we do is we now pick a point on our transformed graph.
Would you not write the one?
No, you don't have to, but I'm just putting it in so you can see that the b value is 1. So now you're going to pick a point on the graph. I'm picking this point, people. Because it's 4 and 1 and it's not a decimal point. I could have picked this one 9 and 1.5, but
You can't pick the start point because they share it?
well, because that's the 0, 0. I wouldn't pick it because it's not going to show you a transformation because they're shared. So pick a unique point. I'm picking, so we're going to pick the point for 1. I didn't pick this one because it's a decimal, and I didn't pick that one because it's a decimal. I'm just staying away from the decimals. We're going to substitute this in for the x and y in the equation. So 1 equals a bracket 1 times 4 minus 0 plus 0. Can you take the square root of 4, people?
Yes.
Yes, you can. We want a by itself. So what did we just solve for? We solved for that a value, which you guys already knew. Right? So if we put that back together, that's going to be y equals 1/2 1 times x minus 0 plus 0. Did I need all this other stuff in there?
Was that by your a? Like 1 equals 2?
Yeah, sorry.
We need 2 forms of the equation, though, right?
Yeah, we're not just,
Oh, sorry.
look, I'm just doing my best. So you guys saw that answer. That was obvious. You didn't need to show me that math, but I wanted to remind you of how we find an equation when it's not that easy to see. Okay? So that's option 1. Option 2.
Can we slow down a second?
Sure, yeah. Okay, we good? All right, so option 2 is not having a vertical stretch. No vertical stretch. Because you guys would agree that this one has a vertical stretch. So no vertical stretch. So that would mean yes to a horizontal stretch. So we're doing the exact same thing we did. We know that h is 0. We know k is 0 because that 0, 0 point didn't move. Now we're trying to find b, and we know a is 1.
What?
What?
Well, we're just saying that?
I don't understand.
Why is A1?
Because we're not going to have both a horizontal and a vertical shift,
Yeah, but
or
if you look
stretch
at
for
it-
this one.
If you look at it, there's no horizontal stretch, right? So we can just
They
make
both,
that.
we're going to create remember cosine graphs? How you could write an equation for a cosine graph and get the right graph, and I could write a different one and get the exact same graph?
Mhm.
You can do this here too.
But why is A1?
Because now we're doing it, so this one, would you guys all agree that there is a vertical stretch? Okay, so this was option 1 for the equation.
Are you using option 1 to find option
No.
2?
No.
I don't.
What does the,
Yeah, I know, but I don't know what you're using 1 to.
so now I'm saying there is no vertical shift, or vertical stretch. I'm saying that there's no vertical stretch, Danica. So that would mean A is 1. Just like when I said there was no horizontal stretch, B was 1. So now I'm going to do the reverse. I'm actually going to find a horizontal stretch here, and it's not the obvious one, because it's not how we would have looked at it. I think we all would have looked at this and done this and walked away. I've never asked you on an exam question, test question, to do it 2 different ways. I'm just showing you there is other possibilities.
So we don't have to know how to do this?
Well, you're going to need to know how to find if there is a horizontal stretch.
So yes,
So yes. Okay, so we're going to fill in what we know. So y equals a, no, a is 1 this time, sorry. B, I don't know. X minus 0, forgot to close my brackets, plus 0. So now what I'm saying is, I think there's a horizontal stretch, not a vertical stretch. Let's find that. So then you're going to pick a point. What point am I going to pick off the graph? 4, 1. We're still going to use that same point. How come I'm not using the other two? They have decimals in them. It has nothing to do with they're better or less. I just don't want to deal with decimals when I square root something. Okay, so we're going to fill those in for our x and y. So 1 equals 1 root b 4 minus 0 plus 0. Okay, so I have 1 equals root 4b. Can't do that. I want to get rid of the radical. Square it. So I'm going to have 1 equals 4b, because the square of 1 is just 1, right? Now I want b by itself. How did I do, what?
no, I know what you did, I still don't get the stretch.
Okay, I'm going to show you, I'm going to graph them, and I'm going to show you that they're the exact same thing.
If you have a vertical stretch in the second one, you're gonna switch it?
It's just a different option, Danica, that's all.
I like.
It's just two different formulas, just like in the unit we just did.
But like if you have a shift and not a stretch, are you gonna use the other shift?
No. Shifts are completely different. This doesn't work if we had shifts. So y equals 1/2.
Why is it?
Okay, so those were the two equations that we calculated, right? Everybody with me so far here? There's the red one. Okay? That's the one that we saw right away that made the most sense to us. I'm just saying there are other options if I needed you to calculate it in a different way. So this was just to show you, just like when we did cosine graphs, there was many other options to do, right? We could all have a different cosine equation, but it would all result in the same graph. So this is it with a compression, and that's it with a horizontal stretch. They are the exact same graph. They lay over top of each other. So all I'm trying to show you is that a vertical stretch can have the same graph as something with a horizontal stretch. You can do it in two different ways. With a slider?
Yeah.
What do you mean?
Like if you shift the amount, like if you shift the 4, it's gonna stretch more or less. Like, okay, if you have 1/2 over there.
Okay, yeah.
It's gonna be taller, right?
It's going to be shorter.
1/2. 1/2. Like if you have 1/2, like
A
on the
vertical
second
stretch
one.
by 1/2 is gonna make it shorter, yeah?
No, like on the second one, if you have a 1/2 horizontal stretch, it's gonna be taller.
So do that.
Yeah, and then if you just put a slider there, you could just show.
I don't know how to put a slider.
You just make x, just put x equals below it.
What?
You can
I don't know. This one got the slider.
I don't know how to put a slider though. I'm asking, do you know how to put a slider?
No, I just thought there's YouTube videos.
It's x.
Okay. So, okay. before we get lost into the YouTube world, which I always enjoy, a new skill I have to do. All right, ladies and gentlemen. Okay, here we go. You're going to create equations with reflections
In each quadrant.
in each quadrant.
Oh my.
Okay? All right. So, in quadrant 1, what would be the equation for this? Hint, hint, it's in quadrant 1. Y equals root x. Good job. Any reflections there? No. Okay, so let's move on to quad 2. So if we reflected it to quad 2,
Y equals root negative x.
so what are we reflecting in? The y-axis, right? So it's going to be y equals negative x, right? Because we just want to mirror it in the y-axis. Yeah.
No, wait, never mind.
Okay, all right. Okay, now we're good. Okay, let's go to quad 4. It will make sense in a second.
Negative y equals root x, and then we have to,
Okay, so we're just gonna,
would the negative be outside the root x? And then equals y?
guys, is this, oh, you know what? Look at this graph. I missed something. Jeez Louise. What is it today with like the walls shaking? What's our 0, 0, 1, 1, 4, 2. All right, what's the equation of this graph? Figure it out. Yep, figure it out.
2.
How? Vertical stretch by a factor of? Can you figure out this equation? Do it. You did say it.
Yeah, vertical.
You've done it.
By factor two.
Okay, so I just forgot the 2 in this one. So if we did it in quadrant 2, it would be, ooh, I have a different color. Okay, all right. The reason why I want to go to quadrant 4 first is because it's a straight reflection. Where does my original graph start? In quadrant 1. In quadrant 2, it was a straight reflection. In quadrant 4, it will be a straight reflection, but it's on
The x-axis.
it's on the x-axis this time. So this one's going to be,
Y equals negative 2 root x.
okay, so let's talk quadrant 3.
Negative 2 negative root x, that's negative 2.
So you need to be over here somewhere, right? So this one would go in quadrant 2, it would look like that. And then where would you need to go?
Down, down.
So we need to do a reflection in the y and then the x. Or we could do it in the x and then the y. It doesn't matter because you're multiplying. So this one's going to be y equals negative 2 root negative x because you need both reflections to get to quadrant 3. Okay. I feel like there's another page to this. It's really, really fast. It really is. It's not hard. What? What am I waiting for? Okay.
Not word problem.
Okay. Super easy, I think. It's super easy. Let's talk turkey, people. Okay. Justin's physics textbook states that speed in meters per second of sound in dry air is related to temperature T in degrees Celsius by the equation given here. Determine the domain and range of this context. It's not. I think somebody just said I sucked.
I
but
said
that's-
you said it was easy.
It is easy.
You just said it's not.
Okay. Wow. I feel attacked. Nicole, I feel attacked.
This math is
Do we have to figure out like the max and min?
Okay. So max and min aren't going to help you too much. I mean, you could graph it, but this would be where the restriction would come in handy, helping you find the restriction on the domain. So remember we did restrictions on those first sets of graphs? So we're looking at what's under the root sign, and what do we know what has to be under the root sign? It has to be a positive number, right? So let's do the restriction for this. Okay, I'm going to do some math for you, just so I'm not a terrible person.
So t has to be greater than or equal to 0. Is that correct?
Well, no, because t isn't the only thing under, the radicand is this whole thing, right?
Okay, okay.
Oh. Do you solve it or do you want it like that?
Okay, let's get a common denominator on the left-hand side.
What? Can't we just transport the one to the other side?
Sure.
Transport.
Okay, I like it. So t over 273.15 is greater than or equal to -1. I've transported it. It's teleported to the other side. Okay, how do I solve for t? Multiply both sides. So t has to be greater than or equal to -273.15. You have just found your domain. What does the domain say? T has to be greater than or equal to -2.7315. So my domain starts at -273.15. And where does it go to? Was that hard?
How do you find the range though?
Okay. So the range is going to be this point, right? Everybody agree with that?
What?
Well, the range is going to start where this, like we need to figure out what the range is at this point for the new starting point. So if you substitute that into this question, what do you get for your, if I substitute this value in for t, what do I get for s? You can do this in your head.
0.
You get 0. Because this number divided by itself, but this one's negative, right? Divided by itself is going to be -1. 1 plus -1 is 0. Square root of 0 is 0. Times by 331.3, still 0. So the range,
But are we ever going to do word problems with like reflections in them?
maybe.
Oh no.
Maybe. Okay. All right. We're doing great. What? How do I know what is?
That's it?
That's it. Because there's no reflections, right? So where does the regular root graph go? It goes to positive infinity. Where does it start? Where on your very first one that we did, where does it start? Where does it 0, 0? Are there any transformations on the y? No. So that the starting point is at 0. And there's no reflection, so it's going to continue to positive infinity. Okay? It is. All right, so this is really super easy. Super duper easy. You're going to substitute in 20 into the equation, and you're going to solve.
What? That's 14?
It's temperature, so it's 20 degrees. So you are going to solve Okay, I would super love for you guys to at least do this first one, just so you know how your calculator works with radicals. Guys, you don't need to be in degrees. You're not doing any trigonometric functions.
Doesn't matter?
Nope.
Which one?
You don't have to, you're not doing a sine, cos, or tan. You're not using any of those buttons, so it doesn't matter if you're in radians or degrees or whatever. Okay, who's gonna deduct me marks on this? No units and
Maybe around to 4 decimals, or, no.
nearest meter.
Yeah, meter, wow.
Okay, so ladies and gentlemen, I feel like I don't need to do all of these with you. They're simply substituting into the equation. I just wanted to make sure you can use your root button on your calculator. Okay? We're done.